Video over this trigonometry pre-cal problem of how to do a word problem that involves simple harmonic motion. So the word problem reads, a variable star is one whose brightness alternately increases and decreases. For the most visible star, delta, whatever that word is, C phi, I don't want to mispronounce, the time between periods of maximum brightness is 5.4 days. The average brightness or magnitude is 4.0, and its brightness varies by plus or minus 0.35 magnitude. Sketch a graph of the problem situation. Write an equation that models the brightness as a function of time. So what I'll do is I'll do both. I'll write the equation first, and then we'll take a look at how the graph might look. Okay, so there's definitely some keywords in here, but before I even talk about keywords, we need to know these formulas that are given to us. D of t is equal to a cosine omega t, or we also have d of t is equal to a sine omega t. Now with these formulas, you have a few things going on. Well, the amplitude, that's going to be the absolute value of a, which a is the coefficient here, the number in front of sine and cosine. The period is going to be equal to 2 pi over omega, and these are all in your notes. And we have a frequency, which I'm not sure we're going to need here. And so let's just kind of get started and see what we need to do. In choosing the formula, it really doesn't matter in most cases. The difference is, if you recall quickly here, that when you're looking at one period of the sine and cosine function, I will do the sine function in I'll do the sine function in blue and the cosine function in yellow. One period of which we know the amplitude of the parent functions are -1. I'm sorry, not the well, we could call it the amplitude, but the range is -1 to 1 of sine and cosine for the parent functions. The sine curve for one period looks kind of like this, and the cosine curve for one period kind of looks like this. And I missed that mark there. Should have went through. Really goes through there, that critical point right there. Now, the reason I say this is because if we looked at this, if I were to look at these graphs, if cosine continues on, it just forever just goes like that, and it makes this type of a motion here, and so does sine. It goes in the same way if I continue on. But again, I'm just looking at one period of these two functions. But what you should notice is that if I took this curve right here and moved it right to this critical point, I would have a sine curve. In other words, if I'm looking at, and I know I use two different colors here, if I go back to this cosine curve here, well, from here to here, this is a cosine curve for, right here, for one period. That is a cosine curve. The cosine over one period is the shape of a U. And the sine curve over one period, this blue piece here, the way I like to kind of explain it is, to me, on those commercials with toothpaste or even a picture on the side of a toothpaste tube, this kind of looks like the toothpaste on the end of when you put that toothpaste on your toothbrush. That's kind of what it looks like. So that's what the sine curve kind of looks like. But if I were to take this this cosine curve that I looked at here, I see this one period looks like this, but I could also, on this yellow line here, which is this cosine curve, I could sketch out a sine curve on that. If I started from here and I ended to here, well, look, I've got that sine curve looking piece here. So in other words, I said all that, and hopefully it's not too confusing, but I wanted you to be able to see that unless there is a specific horizontal shift left or right, we could really use either one of these two forms here. I could use cosine or sine. Those are the differences here. One is cosine and one is a sine curve. So let's kind of go back through here and see the kind of things that we have using our formulas, using our amplitude and our period. And the omega, I didn't talk about that, but this variable omega here, basically what this does is it changes your it changes how your period looks. So your normal period, where it may be for the sine curve and the cosine curve for the parent functions, the period is 2 pi. Well, if that changes, maybe it gets a little bit smaller. Maybe there's a shrink there. Maybe it's 1 pi. Or maybe it stretches and maybe the period is 5 pi. Well, this term in front of t here, omega, that's what affects that. It affects your period. So let's kind of go through here and take a look at these things. Okay, so we have this star, and basically it's getting bright and it's getting less bright, and it's getting bright and it's getting less bright. And it says that the time between these periods of maximum brightness is 5.4 days. Well, it tells you time between the periods. This time between these brightness, lack of brightness and more brightness of the star, this is the period. So that tells me that my period is going to be 5.4. Then it says the average brightness or magnitude of the star is 4. Well, the average, if I go back to this drawing, and I know I've kind of made a mess out of this drawing here, but if I go back to this drawing here, I have a high point and I have a low point. In the middle there is the average, and we call that the midline. And so this 4.0 is going to represent the midline. And that's going to come in handy when I graph. Okay? And then continuing on, and it says its brightness varies by plus or minus 0.35. So what that's saying is that from this 4, it's going to go up 3.5, then it's going to come back down to the 4, and then it's going to go down 3.5, then it's going to go back up to the 4, and then it's going to up 3.5, and so on, and continue to do that. And since that factor is what kind of makes it go up and down from my midline, that's going to be my amplitude. So my amplitude is going to be 0.35. And I said I was going to do the equation first, but let's take a look at this graph. I think it might be a little bit better to kind of take a look at the graph first. Okay, so again, it doesn't really matter if we're going to choose sine or cosine, but let's just take a look at using cosine. So one thing that you should know by now is that you're going to have to look at one period of this cosine curve, and since our period is 5.4, it's not 2 pi, that tells me that omega is going to be some value. I'm going to have to solve for that in a minute. But anyway, regardless of my period, I have 5 critical points that the sine or cosine curve is going to graph on. And it starts at the origin, so there will be 1, 2, 3, 4, and 5. So there's 5 critical points that I'm looking at. Also, this line here that I drew, this is going to be my midline. So this is going to be 4.0 on the y-axis. This is 4.0. So my origin is down here somewhere. And I probably should have drew my midline with a dotted line. And I wonder if I can do that. Let me just do this really quick. I'll keep this solid line as my origin, or not my origin, my x-axis. So this is 0, 0, and I'll call this up here 4, and so this is going to be my midline. But I still have these 4 points that I'm looking at. And it's divided up on the x-axis. I've got this beginning point. I've got 5 points. 1, 2, 3, 4, 5. One, two, three, four, 5. Okay, and the way it works is, remember from the midline, it's going to go up 0.35 and it's going to go down 0.35. So this will be 4.35 and this point will be 3.65. I could have used a different color, might make it a little easier. I'll graph in a different color. So since I decided to use cosine, remember this one starts off at the top here. And so it would start off here and it would go down at kind of at this first point right there. And then to the middle, this first point, and then back up and to there. And that is what the graph would basically look like. Now all I've done is I've sketched one period of the cosine curve, which is that basic U-looking shape. But, so now, if I need to find these critical value points, well, my period is 5.4. So that goes here. So how do I find these other values? Well, this is 1/4 of 5.4. This is half of 5.4. And this is 3/4 of 5.4. So whatever those products are, when you multiply those together, and I do apologize, it's kind of jumbled up, but whatever these products are, that's what these the x values are going to be here. So this first point is 1/4 of 5.4. This one's 1/2, and this one's 3/4, and that will give you the graph. So that gives you a midline of 4, and we knew that because this is the average of the brightness. So it's bright up here, average bright, least amount of brightness, back to average bright, brightest. Then it's going to continue. Average bright, least amount of brightness, and so on and so forth. So that's how you would graph it. So let's take a look at how we would write the equation. And this is mostly just plugging in. The amplitude is 0.35. So right here I'll have d of t equals A is 0.35. And again, I know that because this is, remember, amplitude is kind of like the total displacement, maximum displacement. So it could go up 3.5 from the average and come back down to the average, and it can go down, but it's the maximum displacement from this midline or the average. So that's your amplitude there. Then I have cosine. And then I have omega. Well, how am I going to find omega? Well, I'm going to use this formula over here. I know that my period is equal to 2 pi over omega. So period is equal to 2 pi over omega. And I need to know what omega is. And since I know what my period is, I can plug this in. 5.4 is equal to 2 pi over omega, and then solve for omega. And whenever I have an equation, I'm solving for the variable, and the variable's on bottom of this fraction over here, what I would do is I would make the other side a fraction too, and then kind of turn it into a proportion. That seems to be easier for me. So I cross multiply, so 2 pi times 1 is 2 pi equals, and then 5.4 times omega is 5.4 omega, and then I divide by 5.4 both sides, and I get that omega is equal to, looks like I get 1.163, and so I sub that in here for this omega, 1.163 t, and this is my equation. D of t is equal to this. So I hope that helps this problem. I do apologize. I was interrupted quite a few times with phone calls during the recording of this video, and hopefully I didn't get too distracted in between pausing and restarting. But anyway, basically what you want to do is you want to look at these key terms. Like this tells you time between periods. Well, that is your period. And that gives you the period there. Average brightness. Anytime it talks about average on these things, that's the midline of the graph. That's right in the middle. And then, it goes up and down, 0.35. See this plus or minus here? That tells you that's amplitude, because the amplitude, it's the distance between either from the midline between the top, the maximum, and the midline. It's that distance, or it's the distance between the midline and the lowest part. So keep those keywords in mind, and know your formulas. You have to know what the amplitude is. You have to know what the period is. You have to know your formulas here. And there's even some other problems that you're going to experience where it might ask you the length of a pendulum or something like that. And there's another formula, some more formulas that you're going to need to know. So make sure as you're going through and working these problems that you're taking notes in those sections, because there's some very valuable information in there. Hope this helps.